Hello everyone, my name is Prakash and today I'll be showing you how to deploy a Jupyter Notebook to cloud as a serverless function. So why do we need to deploy a Jupyter Notebook? So I have listed on three main reasons why this can be a good idea. First, having the notebook exposed as a REST endpoint on cloud allows us to iterate faster by calling that endpoint with different data sets and training parameters and generating different models. This also reduces the dependency on engineering and ops team as data scientists are generally comfortable with notebooks and it allows them to push their codes to production without having a dependency with other team members. And it also allows you to expose your data science code as a service to others where other people can invoke your code with their own data sets and generate models custom uh, made and tailored for the various data sets and but very similar to what the GPT-3 library does. So without any further ado, I'll jump right onto the demo. So for the purpose of this demo, we'll be using this notebook, which basically takes as an input data set a time series data for various mobile devices and their battery levels at a different period of times, and it tries to predict the battery level for a future time frame. We'll be using Facebook Profit for as a library for this particular project. And I have the notebook in front of me. It's pretty simple, off the shelf. If I run through the cells, it just loads the data which is present in this input data.zip. And then if I run through the cells, it sort of fits the model and then tries to make a prediction for the next 2 days on a particular device. And shows us the graph that okay, the historical battery level was looking like this and the future battery level are predicted to be in this particular trend. And in the final cell, what we do is we take all the devices, basically in my input data set I have multiple devices, device 1 to 9. We fit the model for each one of them separately, append them to a list, and then pickle all of them together into a single file, so which allows us to make predictions for any device ID at any point of time. So now our intention is to deploy this notebook to an endpoint so that we can call that endpoint to train the data sets from different devices. Apart from these 9 devices, I can have 100 or thousands of new devices for which I want predictions for. I should be able to pass those data sets to this endpoint and get back my pickled model file. So there are two prerequisites that I need to take care of before this notebook becomes deployable to an endpoint. The first one is that I have to make sure that all my input parameters are clubbed together into a single cell, and then we have to go to that cell selected and go to this gears icon and tag it as parameters. And but what this will allow is once this Jupyter Notebook is deployed, any variable that I have defined in this particular cell can be passed as an input to the REST endpoint, and it will be dynamically replaced at the time of invocation of this notebook. So it's pretty cool. We can also call that REST endpoint with a file input with a variable name file, and it will automatically upload that dataset file and make it available into the serverless function and replace this variable with that local path. Also, any output that my notebook generates, I have to make sure that I define a variable called output file path, which is basically a folder location where all my output files will be saved. And the name of the variable is of importance. It has to be exactly this. So what will happen is once I deploy this notebook, any this output file path, anything that is being saved to this particular path will automatically be packed up into an S3 bucket, and when we invoke the REST endpoints and once the execution is complete, we should be able to get back all those files, S3 URLs for all those files for future references and downloads. So that's all that we need to sort of do in this notebook. And also, I mean, if you want, you can designate cells, select a cell and mark it as an tag it as output. Then an additional thing that can happen is along with the output files being uploaded to S3, the cell output can also be returned to back to you once you invoke that endpoint. So once we have done these changes and make those, so only we have to tag the input and the output cells, and we save this particular notebook. We are all set to deploy it to the cloud endpoint. So we'll be using Clouderizer for this deployment. And in case you don't already have an account for Clouderizer, you can go to clouderizer.com and sign up for a free account. So here we go ahead and do a new project. We name it battery forecast. We select the type training here, press next. We select our Jupyter notebook. We select a requirements.txt file, which basically lists down all the dependencies that my notebook has. I press finish. And in order to deploy it, the first step is to press save over here, which will ensure that all my code and requirements.txt gets synced with their version control. Yeah, you can see it is now saved successfully. Now I go ahead and press deploy, and I select Clouderizer cluster. It's a Kubernetes cluster hosted by Clouderizer, on which we would like to deploy this notebook. Go ahead and select that. And then this kickstarts the deployment process. And it probably will take 5 to 6 minutes, because it has to build a new Docker image and with all the dependencies for my notebook, and deploy it on Kubernetes. So I'm going to pause this video until this deployment is complete, and we will resume it back in a moment. Hi guys, I'm back. So we can see that the project is under running status right now, and we also have a curl command exposed over here, which can help us invoke this particular endpoint. So I'm going to copy that and head over to a terminal, and let me paste this command over here. So you can see this command has a header called callback URL, which accepts a webhook. And the reason for that is that because the training can be long-running processes, the HTTP request will return back immediately with a 202 code, and then once the training gets completed, this particular webhook gets invoked, posting the result of the notebook invocation. In case you don't have any web application publicly available which can receive these webhooks, I suggest you can use a service called webhook.site. So you can just go to webhook.site. It automatically generates a webhook URL for you, which you can copy from over here, and then just paste that URL into your curl command under callback URL header. And in addition to this header, we also have a file parameter where I'm passing the input data set. The name of the parameter, as you can notice, is exactly same what I had in my notebook. So here also the input data dataset parameter name was file, and I'm using the exact same parameter over here. So I'll go ahead and press enter to invoke this curl command, and once I press enter, you can see I get a HTTP 202 accepted. And now if I head back to the webhook site, it is still waiting for the first request. And once the training gets completed, we should see a post message from Clouderizer into this webhook, and here it comes. And if I go into the details, you can see the raw content for this particular message. It shows me that the pickle file got generated, and this is the path of the pickle file. It is also giving me the complete text cell output for the output cell that I have marked, and also in the end, it has a beautiful S3 URL for the pickle file that got generated. If I copy this URL and I go to a browser tab and enter it, the pickle file gets downloaded from this training. So in addition to that, also, if I go and head over to the analytics section of this particular project, I can see the requests, all the requests that I have made so far to this particular endpoint. They're all listed down in a nice list over here, and you can go inside more details. The notebook output gets displayed over here. The input files can be downloaded, output files can be downloaded, and the complete history is being maintained over here. So this is all that I have, how you can deploy a notebook to a serverless function on cloud. In case you guys have any questions, feel free to reach out to us on clouderizer.com or email to us at info@clouderizer.com. Thanks a lot.